Okay, so pick it up again where we left off. We were graphing rational functions using all the good stuff to graph these functions. Okay, so we did get to two different types of ones, so that's what we're going to do now, and then you guys will have opportunity to go back to the problems from your homework, take a look at those, and then complete those. Okay, so we're back on page. Hopefully, you're on page 55. You're on page 55 in this graphing process, okay? So first off, I know we're just graphing, but it's always good to practice this. What is the domain of this rational function? X such that
X can equal -3 or -5.
That's your word. X such that X cannot equal -3, X cannot equal -5, and X is the element of all real numbers. Yes, he's not question.
If it's the same number from like square, could you just write plus minus and you want to square it on both for the does not equal?
What's your right? All right, so now let's see, are there any holes? Any holes?
No.
There are no holes. How do you know when you have holes? When something cancels out, nothing cancels out here. It's actually already in its nice factored form, so that's actually kind of nice. So from here, let's find the vertical asymptotes. What are they? Careful. Write in this equation, so it will be x equals -3 and x equals -5. All right? So this is one where we have 2. So this one is different from the other 3 that we did before. This one has 2 vertical asymptotes. Do we have a horizontal asymptote or do we have an oblique one? Say again, sir? It is horizontal, and more specifically, is y equals 0. Because the denominator's degree is 2, because you have an x and an x, so multiply and give you x squared. The denominator is bigger than the numerator. We good? Alright, so if we have horizontal, that means we have no slant. So let's go with x and y intercepts. X-intercept is 6, 0. Raised hand. How do you find x-intercepts again?
Set the top equals 0.
So the top equal to 0. Y-intercept. Raise your hand. How do you find the y-intercept?
Zeros for x.
Zeros for x. So when we plug in zeros for x, that'd be -6 over 3 times 5, which is 15. That reduces down to be what?
2 over.
-2 over 5. So let's go ahead and let's plot these. We have 0, -2 over 5, which is like right here. And then we actually have an x-intercept on our horizontal asymptote. Yes, this can happen, okay? Realistically, horizontal asymptotes, they tell you more about your end behavior. What the graph is approaching, the bigger the x gets, closer to positive infinity or negative infinity. That's what the horizontal asymptote does. Which means that, yes, you can cross the horizontal asymptote. Vertical asymptotes, however, you never cross or touch. That literally does make the function undefined. Okay? So, when you're thinking of curves and you actually have a point that's on your horizontal asymptote, it is going to cross over that, but then it's still going to be very close to that asymptote. Okay? It's still going to approach that value. Now, in situations like this, you might want to plug in a few more points just so you can have an idea of where the rest of this graph is, okay? So I already know what's happening to the right of x equals -3. What's the number in between -3 and -5?
Negative.
Plug in -4. See what is happening. What is that y value when x is -4? Go ahead and figure that out. Figure out that y value when you plug in -4 for x. And what do you get? Is it +10 or -10? Okay, I hear in the mix. When you plug -4 in, what's -4 minus 6? -10. When you plug in -4 at the bottom, what's -10 be a positive 10. So at negative 4, you're all the way up here at positive 10. Okay? And you can plug in some points in between, but this actually is going to look like a little parabola. Being bounded by those asymptotes, still heading in the upward direction. Yeah. Bless you. Now plug in a value that's to the left of x equals negative 5. What's the value to the left of x equals negative 5? Negative 6. Plug in negative 6. Find your y value. We're just trying to get an idea of where these other curves are. Plug in negative 6. So you have negative 4 when you plug in negative 6 for x. So negative 6, negative 4. Okay? This part of the curve, okay? It's not going to be crossing back over your horizontal asymptote. If it were, then you would have another x-intercept. But since you don't, you know your curve is approaching both asymptotes in both directions. Just like me. I ran out of space too, but I drew it in my open area. On this side, of course, we're approaching the vertical asymptote. We are going to cross the x-axis at 6, and we are still going to continue to approach 0, but as the larger that x gets. And yes, it looks a little strange, but that is the graph of that rational function.
Can I have a new homework sheet?
Alright, this one. Okay? Here's the last one. Here's the last one of graphing. Okay? If you notice, all 5, they've all been different. Okay, the first one was your more basic one. Okay? Had one vertical asymptote, had a horizontal asymptote. Then you had another one. Then you had one that had an oblique one. The last one had 2 vertical asymptotes. This one's going to have, what happened when we graphed it? Something with a hole. This probably has a hole. Alright? The domain. The set of x such that x does not equal 1 and negative 3. X is an element of
All real numbers.
all real numbers. Okay? Real quick. Looping time. What is that? Integers. That's integers. And what is this? Rational. Rational. Think quotient. So that would be Q. Alright? So, back to this. Do we have any holes?
Yes.
Yes. The x minus 1s cancel out. Which means that there's going to be a hole when x is 1. What's the simplified version of this?
1 over
1 over x plus 3. The top is gone, but there's still there's still a 1 up there to create that fraction. So the hole is at 1, comma, 1/4. And what does the hole look like? It literally looks like an open circle. So please, when you are graphing your holes, I need to make sure I can make out that it's not just a regular point, but it's actually an open space there. Okay? 1 and 1/4. Do I have any vertical asymptotes? Yep. X equals. Remember, you get that by setting your denominator equal to 0.
So you wouldn't go back to all because you want.
No. To get your vertical asymptotes, you always go off of the simplified version. Because technically, that first point of discontinuity, that 1, that's a hole, not an asymptote. So you don't want to count it twice. What's our our horizontal asymptote? Yep, y equals 0.
denominator equals 0.
And real quick, reviewing the horizontal asymptote, when the numerator is less than the denominator, it's y equals 0. When they equal, it's the y equals the coefficients of the top and the bottom. But when it's bigger, you gotta do synthetic. And are we concerned about the remainder?
No.
No, we're not. Okay, let's see. Do we have, what's our y-intercept? 1/3. And do I have an x-intercept? You do that by saying the numerator equals 0 and 1 equals 0 is not possible. Do you kind of see where your branches are? Are we crossing over our horizontal asymptote? No, we don't have any x-intercepts. So our curve should definitely go through our y-intercept, kind of pass through our hole. Like so. But where's the other branch? It is going to be in the bottom left. If you're unsure, pick a point that's to the left of that vertical asymptote and plug it in. Do you have to plug it into the original? No, not really. You can plug it into the simplified one. And you would end up with a, and that proves that it's going to be in the bottom left. And there you go. There's one with a hole.
What if,
When in doubt, it's an equation for a graph. If you literally get to the point where you're like, oh my goodness, I don't remember anything, what can you do to graph this? An XY chart. Yes, may take you a while, okay? But if you're able to get all the information and you're unsure of like certain places where the point should go, then just plug in a few. It's fine, go ahead and do so. Just make sure your math's right.